All right. What's cracking? Okay. What's up, everybody? Welcome back in. We're having a good day today so far. Gonna be jumping back into. Oh, hold on. Let me start Twitch. Shoot. Oh gosh. OBS needs to update. The new update sucks. It doesn't remember any of your accounts. Nothing. Okay. Cool. Let me go here. Streamlabs. Okay. Cool. Nice. All right, I think we're good to go here. What's up, everybody? Welcome back into the stream. Hope you're having a wonderful day so far. Today, we're going to be jumping back into C Programming, A Modern Approach, 2nd edition by K.N. King. Going to be taking a stab at the last couple of projects in the programming projects for the end of Chapter 8. Hopefully, we can finish up Chapter 8 today and move on. Let me turn this light over here. All right, hopefully we can do this. What's up, Chuck? What up, Chuck? I like that. Okay. Put this over. No, that's fine. Okay. Cool. Okay, here we go. Let's go get into this one. All right, we're on number 15 here. This one's been getting harder and harder, so pause. That's what she said. Okay, here we go. Number 15 of Chapter 8, Programming Projects. Some C Programming, A Modern Approach. 2nd edition. One of the oldest known encryption techniques is the Caesar cipher, attributed to Julius Caesar. It involves replacing each letter in a message with another letter that is a fixed number of positions later in the alphabet. If the replacement would go past the letter Z, the cipher wraps around to the beginning of the alphabet. For example, if each letter is replaced by the letter 2 positions after it, then Y would be replaced by A and Z would be replaced by B. Just a shift cyclically, right? Write a program that encrypts a message using a Caesar cipher. The user will enter a message to be encrypted and the shift amount, the number of positions by which letters should be shifted by. Enter a message. Go ahead, make my day. Enter a shift amount, 1 through 25. 3, encrypted message, JRDKHDJ. Notice that the program can decrypt the message if the user enters 26 minus the original key. go ahead and make my day. You may assume that the message does not exceed 80 characters. Characters other than letters should be left unchanged. Lowercase letters remain lowercase letters when encrypted, and uppercase letters remain uppercase. Hint, to handle the wraparound problem, use the expression character minus a plus n modulo 26 plus character a to calculate the encrypted version of an uppercase letter, where the ch variable stores the letter and n stores the shift amount. You'll need a expression for lowercase letters. You'll need a similar expression for lowercase letters. Write a program that tests whether two words are anagrams. Oh, that's a different problem. Okay. Cool. So we're going to do the Caesar cipher again. I think we've done this one before in Python, in our DSA in Python book. Little Wendy's cup. Wendy's nuts. Sorry, y'all. Sorry. If you're part of the early crew, leave a like on the stream. Appreciate you guys being here. My headphones are charging right now, so we'll get some tunes going in just a second. But let's get this started, huh? Okay, so let's include the standard io.h header file, int main void, and open this up. So we have a char array that's going to be letters, or we'll say phrase, and this is going to be size of 80. Okay. So it's 80 size. Okay, we're going to have an int called shift. Cool. All right, let's go ahead and get this going. So we're going to initially call a printf statement to the terminal where we'll enter message to be encrypted. Okay. We'll leave it at that. We're then going to call a while. We'll call this char character. We'll call it C. While C equals to get char, and this value does not equal to quote \n. So we're going to continually loop and get the characters from the input one by one, and then we're going to decide how we're going to shift those, right? Okay, cool. So we'll call this original phrase. We have a char array for what's it called? It's not decrypted, it's encrypted. Encrypted phrase. Okay, and this is going to be size 80 as well. Okay, so now what we're going to do is we're reading the characters into the original phrase, right? We probably don't even need to store the original phrase. We probably can just encrypt each character as we go here. To handle the wrap problem, use the expression of this, where this is for the uppercase. Okay. So if the character So let's open up an ASCII table. Okay, let's open up an ASCII table here. Hey, Silva. Welcome back in, my boy. Silva's back. Guess who back? Silva back. Okay, so if the character is between 65 and 90 inclusive. So if the character, so we'll do, this is going to be, let's make a note here, uppercase. So if the character, or if 65 is less than or equal to the character, or the character is less than or equal to 95, right? No, 90. So if the character is greater than this or less than this, no, it wouldn't be or, it would just and, right? Okay, cool, yeah. So then we would go ahead. Hey, Tim, welcome back in, my boy. You've been watching much basketball lately, Tim? How has your team's been doing? How's Boston been playing lately? So if we're gonna be in the uppercase for the character, oh, we also need to enter a shift amount. Okay, so hold up. Oh, okay, hold on. So I'm gonna actually get rid of this real quick. So what we're gonna do is we actually need to read this into the original phrase. Original phrase index. Okay, so then we'll say I is equal to int I is equal to 0. And then I guess we will go original phrase index of I is equal to the character. And then what we're going to say is if the int, or sorry, if the character, if the int nothing, if I is greater than 80, right, we're gonna printf message error message too long, and then we're gonna return 1. So that'll handle that. And then original phrase I plus plus here, that'll take care of that. So that'll increase I all the way through. And so now we need to actually go through the original phrase. Okay, so we're going to say for int j equals to 0, while j is less than j plus plus. Right, we're going to loop through our original phrase, and actually what we need to do first is we have to printf and say enter shift amount 1 to 25, like so. And then what we're going to do, I guess, is we're going to do a scanf here, and we're going to read in an integer, and we're going to read this into the shift variable. Okay. What I'm going to do, though, is I'm going to say if shift greater than, if shift no, I guess we'll do another while loop. I mean, we're kind of being a little overkill, but so we'll say while shift is less than, well, shift isn't initialized here, so we'll initialize shift to 0, and we'll say while shift is less than or equal to less than 1, or shift is greater than, we'll do like this. Yeah, shift is greater than, what is it, 25. Then what we're going to do is scan F for shift. We're going to scan F for the shift. Yeah, if it's less than that or greater than that, then go ahead and repeat the scanf. Will that work? So it'll print this. In our first iteration, shift is 0, so it will enter for this scan. If they enter values, it'll read it into shift. Shift gets updated, thus changing the while loop, making go back, reevaluating the condition, right? And if it's still there, then we keep going. We can try it out. Thanks for Anthony Simons. He had 40 points today. Is he on Boston? I forgot about that guy. Honestly, 40 points, good for him. That's pretty nuts. Okay, so we enter the shift amount, we'll read that into shift. Okay, so then what we'll say is for j equals to 0, while j is less than or equal to I, j plus plus, we're going to say if original phrase index of I greater than or equal to, no, if 65 is less than or equal to the original phrase and the original phrase is less than or equal to 90, right? This is for the uppercase condition. Then what we're going to do, original phrase index of I, rather, sorry. Sorry, this is not I, this is J. Whoops. So if the original phrase is in between the uppercase range, then what we're going to do is apply the formula here. So we're going to say, use the expression this to calculate the encrypted version. N stores the amount of shift, and C is that stores the letter. So it's going to be the character, original phrase, index of J, less than, quote, A, plus the shift, mod by 26 plus the character A. So this will give you the char new C, right? Or we'll say like shifted character. So this is the shifted character for the uppercase. Okay, yeah, I think so. Okay. And then we're gonna do shifted, or we're gonna do encrypted phrase. Okay, what we can do actually is we'll go like this. We will set a char new C, we'll say encrypted C, and then what we're going to do is override this encrypted C as this. Then we can get rid of these brackets, just clean that up. Then we'll say else if, so this is going to be the lowercase. I'm going to take this expression, right, so in the lowercase, it's going to be 97 to 122 inclusive. 122. And then the char encrypted is going to be minus A plus A. Okay. And then I guess we'll just say else original phrase, or we'll say char. We don't need to redefine char encrypted because we initialized it already or declared it. So else we'll say encrypted C is equal to original phrase index of J. And then at the end of this loop, within the loop, no matter what, we're going to set the encrypted phrase index of J equal to the encrypted equals to the encrypted C. Right, so we declare the encrypted C. If it's within the bounds of the uppercase ASCII characters, we're going to override the encrypted C variable to actually house the wraparound expression for the capital A. Else if it's the lowercase bounds, 97 to 122, the encrypted C then gets overwritten for the lowercase a wraparound expression. Else if none of those are true, meaning that we're just a normal character, or a space or whatever, then we're just going to set the original phrase of that jth index to the encrypted C of that jth index. Oh no, equals to the encrypted C, right? And then we set the encrypted C, no matter at the end, the final encrypted C to the actual encrypted phrase. Should we try it? No error, no way. Michael, or we'll say go ahead, make my day. Oh, I didn't print. Shoot. Okay. Okay, we almost got that if I would have just remembered to print. Hold on. We didn't get any errors though, so let's just chill. Okay, we're gonna say for um, int j equals to 0, j less than I, j plus plus. So we'll rewrite j here. And we're going to say is printf, and what we'll actually say here is printf. I guess I could print it here, but whatever, I don't really want to. I'll loop again. I will say encrypt. Oop. Like this. And then we're going to printf %c for the encrypted phrase index of j, and we'll leave it at that. And then we will call a printf to \n and return 0. Okay, let's try this. Go ahead, comma, make my day. 3. Dang it. Dang it. Dang it, dang it, dang it. So we're actually not getting anything in the encrypted phrase. Let's go here and call a printf to %c, and let's do the encrypted c, and let's see what output we get for that. Michael. Nothing. How's it going? R858302. Yeah, we're using this good book. Good book. Okay, what's going on here? Well, let's see. Are we getting any... Let's call printf here and see if the shift is working. Yeah. Okay. The shift is working. I'm going to go here and print f to %c the original phrase index of j and see what we get. Okay. So the original phrase, maybe it's this. Huh. Okay, so it's something to do with our... Let's take this. Hmm. Why isn't our characters being picked up here? We're not even printing anything. Should be printing right there before the enter shift amount. Put a space before %C. Oh, to see if this is even entering. It's reading in, or it's printing that, but it's not printing in the character. Hmm. How does it work? It's printing the LOL. Hmm. No, that space I put in there. It's not, I don't think it has anything to do with this space here. Could be wrong. Yeah, I don't know. Recharge. Oh, I'm stupid. Order of operations, that's my fault. Wait, what did I just do? There we go. My bad, I'm missing my parenthesis right there. Okay, cool, we solved that bug though. Glad we were able to work through that. Okay, now let's try this one more time. Okay, I think I should get this one. Okay. What we're gonna do, go ahead, make my day. Yes! Let's go! Okay, I'm gonna take this and we're gonna try it again. Paste this in here. Do 23. Yes! Okay. Boom! Moving on. Moving on up. Just a small bug, dude. Just one parenthesis was causing our... One missing parenthesis. We had a bug. See, brutal like that. I kind of like it though. It's fun. It like makes you actually act, be a programmer. You gotta get it right. You gotta be a programmer. Okay, here we go. Next up, number 16. Write a program that tests whether two words are anagrams, permutations of the same letter, of the same letters. Okay, I'm not even gonna look at the hint here. I think I know how to do this one right away. Include the standard io.h. We're gonna go in main void. Okay, let's go. We're gonna go char abet. This equals char abet size 26, and we're gonna default these all to 0. Okay. And then what we're gonna do is call print f, and then looks like it wants us to use lowercase, so let's use the toLower function, which is in string.h, I think. We're going to include string.h question mark. Okay, so we're going to print f and say enter first word. First word. Okay, then let's call char c while c equals to get char, and that does not equal to \n. Let's go ahead and read through these characters. We're going to go C, or two, we're gonna go, what's it called? Is it toLower? Yeah, toLower of C. And what we're gonna do is say mod 26. We're gonna go, this is an index value into abet and plus equal 1. Okay, I think that'll work. And so then okay, we force every character to lower no matter what, which is fine. Unless if is alpha of the character, right? Then go ahead and do this. So if the character is alpha, go ahead and do a lower force to the character, mod 26, to get its index value modded down to 26, and we'll go ahead and increase the alphabet character count for that. And then that's the original. And then I guess to do this, we would need to, we would have to do this a second time, right? For the second word. Yeah, abet 1, abet 2, and then we have to loop through and identify if all the values are the same. It's getting way quicker. I mean, but you can't maybe like do a logical check until the very end because you won't know, okay.
You're not that
Well,
guy,
for
pal.
like the
Trust me.
case of
You're
if
not
you
that
have
guy.
too few of characters in the second letter, right? If you have two
Absolutely.
T's in the first word and one T in the second word, you can't make the final call until you go the entire length of the word, right? You have to go basically O of N. You have to go in the entire length of the word in order to determine that. But you can cut off early if you meet a character that actually goes over the count of the first, right? That can be an early cutoff. But you can't cut off early just because you remain lower. You can only do that if you actually finish because what if the last character was like a T and you say, okay, right? So you can't determine. I guess you could sum. No, summing wouldn't work because you need to determine the exact index placing, not just the total sum. So it could have the same total length of characters, but not the exact placing. So yeah, I guess we have to. I say ABAT first, and then we'll go ABAT second here. And then what we'll do is do the same similar process here, but we'll say enter second word, right? We don't need to redefine or declare a char C. We can just override it, do the same thing here, but this will be this is ABAT first, and this is ABAT second. Oh no. Who was that, the sub? Let me get you, where was that? Who goes that? Ashkan, thanks so much for the sub, dude. Appreciate you joining me. That's awesome. You're a beast. You're a beast. We can get some tunes going if we'd like. Hold on, we'll finish this problem. Okay, let's keep pushing. So then we're going to do that for ABAT second, and then I guess we need to say for int I equals to 0, I less than 20 or 20 what 27? No, 26 because it's 0 index. Ooh, what happened there? Plus. Okay, and then we're going to say if no. Okay, so if the ABAT first index of I is equal to ABAT second index of I, then we're going to continue. Well, I guess we can just do the second or the opposite here, and we're going to print F. What did I say? The words are not anagrams. And then we're going to go return 1 here. Else we'll just continue through the loop. And then if we do actually get through the loop without returning, we're going to printf the words are anagrams and \n, and then we'll go return 0 here. Okay, shall we try? Okay, let's try it. Oh. Oh. Oh, Oh, C, type. It's not string H. Oh, my bad. Chat didn't let me know. Oh, why do I keep doing that command? Smartest. No, really? Oh, these words are anagrams. Yes. Okay. Okay. Good. That's right. Dumbest. That's me. And stumble. Yes! Let's go. We're cooking through these problems, boys. We are cooking through them. All right. Last one of the chapter. Let's go. Feels good. What's going on? Command. The return one just means that something like went wrong. Typically, that is just like you return early one because something went wrong. Return zero like nothing. It just went through. Like that's kind of like the, I guess the standard syntax people usually use. I don't know. I don't know. But yeah, we just return early if you don't equal because you don't need to go through the end of the loop at all. But if you actually get all the way through, you are anagram. Boom. Cool. And we can probably solve the the leak code problem anagrams now in C. Should we go copy the script over? Just got the script. I'm working. So happy. Nice. That's awesome, dude. Congrats. We were doing pretty good here on these C practice problems here from C Programming: A Modern Approach, second edition. So we're feeling pretty good too. Thanks for joining me here. Welcome into the study sesh. Appreciate you being here. You guys are new. My name is Michael. I'm 26 years old, about to turn 27 next week. Kind of crazy. Dude, that's so wild. 27? Like late 20s. Wow. Old man. Um, yeah, I'm going to be 27. I'm 26 right now. I have a degree in human bio, minor chemistry. I graduated from Utah State back in 2021, end of 2021. December, and I got a job at the very beginning of the new year, 2022, as a chemist for a biotech company here in California. It's been fun. It's been a good experience so far. I've been teaching myself how to code, though, for about a year and a half after my 9 to 5 job. First, we started with Python, doing various courses like Harvard CS50P, CS50X, reading books like Python Crash Course, Fluent Python, DSA in Python, and alike. Doing MIT OpenCourseWare classes in Python, and then making our own Python projects. We don't really watch tutorials. We just build our own stuff and solve problems from books and read books, which has been kind of fun. It's been we've been able to learn a lot. So now we're kind of going into C because I felt kind of bottlenecked in Python, kind of understanding what was actually going on. If I ever wanted to maybe write my own scripts to then pour into Python, I had no idea how to do that. I would have to learn C, probably something like that. So we've been trying to teach ourselves C and get better at it. And it's been actually a lot of fun. I kind of like the way that it's more manual and it makes you feel like you're more involved actually writing code rather than just calling functions that are abstracted away. I don't know. It kind of gives you like that Mark Zuckerberg in the Social Network feeling when he's like grinding in the dorm room. Utah State's finest, bro. No. I gotta put my degree over here. It's like I have a frame. I put it in a frame, but the frame broke. So I gotta get a new frame. It's just sitting up in the cupboard, collecting dust. My, $50,000 diploma. Oh, America. Okay, here we go. Number 17, last problem of the chapter. Oh, bless up. Last one here. Write a program that prints an n by n magic square, a square arrangement of the numbers 1 to up to n squared, in which the sum of the rows, columns, and diagonals are all the same. The user will specify the value of n. Oh boy. This program creates a magic number of a specified size. The size must be an odd number between 1 and 99. Okay, so before we go any further, okay, let's read this little excerpt here. Store the magic number in a 2D array. Start by placing the number 1 in the middle of row 0. Place each of the remaining numbers, 2, 3, up until n squared by moving one row and moving up one row and over one column. Any attempt to go outside the bounds of the array should wrap around to the opposite side of the array. For example, instead of storing the next number in row less than 1, we would store it in row n less than 1. The last row, instead of storing the next number in column n, we would store it in column 0. Yeah. If a particular array element is already occupied, put the number directly below the previously stored number. If your compiler supports variable length arrays, declare the array to have n by n. Oh gosh. This one might be a little bit of a doozy. I'll try this one out. Call it less. Just hung up my bachelor's degree yesterday. Nice. Okay, so let's just get this started. Okay, so we need to have a printf that states this program creates a magic square of a specified size. The size must be an odd number between 1 and 99. Printf, enter size of magic square. And we're going to read this into int size, and then what we're going to do is we're going to scanf for the actual size value and save that in. I guess we'll say while size mod 2 does not equal to 0, we're going to do this scanf and read it in to size. So this will make it so size has to be odd, right? So it has to be odd, and size less than 1, or size greater than 99. And what I'll do is I'll short circuit this one out front here. And both these conditions have to be true. Has to be within this range and the number itself, size, has to be odd, not equal to mod 2, 0. Right? Mod 2 cannot be equal to 0. So we'll repeatedly scan that in until we get an odd number. So then we need to create a int matrix, which is going to be size by size. And we're going to, I guess, default all the values to 0. Okay, now let's get into the nitty-gritty here, what this entails. So start by placing the number 1 in the middle row of row 0. Okay. So we know that it's an odd number, so we know that there will be a middle value always of the length of the rows, right? So it's just like 5 divided by 2 is 2.5, so just mod, or just floor the value, integer division will give you the index 0 at the middle, because we're always even, or always odd here. So I guess what he said, okay, so we're going to go for int I equals to 0. Well, I is less than size times size, right? Size squared. Right, n is the size, right? Yeah. What we're going to do is increase I forward up until the power of 2. And I guess we're going to place, do we place 25? No, we place 24, not 25. Yeah, we do place 25. So actually this is runs on this one, and this goes from 1. Okay, so then I'm going to say int row and column. And so row is going to start off at row 0, and column is going to be size divided by 2, right? So then what we're going to do is we're going to say if okay, I got you. So if so we need to determine if the next cell is available.
You're not that guy, pal. Trust me. You're not that guy.
Okay.
Yeah?
You?
Absolutely.
Absolutely. So we need to determine if the row, so we're going to first place matrix index row index column is equal to 1, okay? And then we're going to say row is equal to row is equal to, we're going to move, say what? One row up one row. So row is going to be equal to row plus 1 mod by the size, right? So this will increase the row by 1 value modded by the size. So if we're on row 0, we go up to row 1, but we can't go up to row, no, because moving up a row is technically going down a row, so it'd be row less than 1 modded by size. So this would be row -1 modded by, ooh, so -1 modded by this size. Oh, I forgot about negative mods in this. This one's size of 5 here. -1 mod 5 in C. That equals to -1. And we would want to go to n-1. So if you did plus, that would go to 1 mod. You do 5 mod the So I'm trying to think, like, if we do we mod by size, or does size mod by row less than 1? Be 0. No, I'm trying to think here. So we want to, if we go up a row, we need to wrap to the next, down the next row. Row less than 1. So we have to do. So 5 minus. I'm kind of confused on this one. I'm trying to figure out the wrapping of the row. Right? One sec. Check my phone. Wrapping of the row. So a row has to go up one, right? We went. I guess we'll say if row less than 1 is less than 0, then row equals to size less than 1, else row less equals 1. And I guess we'll do a similar thing for column. So if column so we have to go over to the right one column. So column plus 1 is greater than it's greater than 4. Size less than 1. So if the column plus 1 is greater than the size less than 1, right, then what we're going to do is set column this exceeds equals to 0 wraps to the 0 column, else column plus equals to 1. Okay, so then what we're going to say is if the element is taken in the new column and new row. So if matrix row column is greater than 0, right? If it's greater than 0, then you know we need to place directly below the current value we were on. Right, which was currently a row column when we already did it. So what we have to do is keep track of each iteration. So we have to say int previous row equals to row, previous column equals to column. So if there is a value at here. Then we're going to save matrix index previous row previous column. Now this is row plus 1 under the same column. Yeah. Is equal to I, right? Else, if there isn't a value at the next row and column, then we're going to set matrix index row index column equal to I, and then continue looping. Let's try it. GCC dash O. Ooh. Ooh. Pop. Variable size object may not be initialized. So can I not set these like this? Oh, then I probably have to set all of them to 0. Segmentation fault. What's a segmentation fault? Hey, how's it going, Danger Noodles? Appreciate you joining me here. Welcome back in. Attempts to access memory is not allowed to access. So this creates a magic square, and then here, and then we segment fault here. Oh, we do an evaluation on a memory that isn't initialized. Oh, what the heck? So size is 0. While size is less than 1, or size is greater than 9, and size mod 2 does not equal 0. Well, it's not even asking me. I'm not even printing. I'm not even getting into here. Enter size of magic square. Let me go back to this one. I'm gonna maybe do like this. No. Okay, what I'll do is this. I'll say while 1 scanf if so if size is less than this, then we're going to print f, say size is not in the correct range. Else if we're gonna say, we're gonna continue. Else if this, we're gonna say printf, say size is not an odd. We'll say while true, print this. I guess we'll say that. Into there. I don't know why I'm having trouble with this part. This is kind of strange. What was that? Oh, apply continues. Sorry. Okay, now we can do it. Okay, so what's the logic then, I guess? So I say, let's go like 100. Let's see what happens. Size is not in correct range. And let's do a backslash in here. And then I guess we'll go like this. I guess I'll put this in the loop. Okay, if I do like 100. 99. Size must be odd. It is odd. Oh, that's why. My logic probably was right. I just had the wrong... Oh, I'm so dumb, dude. Sorry, yo. I'm gonna go back and do it how I had before. I don't know why I had it like that. The size is equal to... No. Why isn't this statement wrong? Why is this statement wrong? I want to know. I'm going to go to the orb here for this one. Why is this wrong? The logic there. Okay, so if it's an invalid range. Okay, we want to do, this is making acceptance. Okay, so we want it to be valid. So if the size is greater than or equal to 1, or less than or equal to 99, and the size mod 0 is equal to, that's what we wanted. Bruh. No, we want to continually scan F. So this would be is less than 1 or size greater than 99 or size mod is equal to 0. We're going to keep doing this. Yeah. 100 keeps going. Okay, so then let me go like this. I'll take this, put that there, delete, there we go. Okay, oh, delete that, sorry. Okay, try that one more time. Let's go 100, 0, nice. 99. Okay, so that went through. Now let's loop through for, let's take this right here, and we're going to call a printf for the result. We're going to go here. Okay. We're going to call a printf to this. What's 99 times 99, so I can just know the maximum? 9,000, so 4 digits, so we'll go 4 spaces. It looks like that's what it is anyways. And we'll do a quote %d 4 spaces, like so. And then we'll call a printf here for a new line after each row print. And then we'll call a printf, or we'll go there. Okay, let's see. One, 2, 3, 4, 25. What the heck? Uh-oh. Ah, shoot. So we saved the previous row and previous column. If the row -1, meaning we're trying to go up a row, right? If the row -1 is out of bounds, meaning that it's less than 0, then we're going to set the row equal to the maximum row, which is size 5 less than 1, which is 0, 1, 2, 3, 4, right? Else, row less equals by 1. Yeah. So same thing for the column, but if the column increases to the right out of bounds. If the column is greater than size minus 1, then the column gets set to 0. So if column goes greater than 4, then it resets to 0. Else column increases by 1. If there's a value greater than 0 at the next matrix position that we calculated by increasing row and column, one up to the right, up and to the right, right, then we're going to override, we're going to use the previous row and then what we're going to do is set row equal to previous row and column equal to previous column, right? That becomes our new row and column for the next go. Whereas this one, if we just place, we keep moving. Okay, I think that might solve it potentially. No. So the thing is why is that not increasing? Why is it setting 1 there, 2, then 3, then 4? Can't go there, then it says 25? So if the value that we want to place on is greater than 0, then we're going to go to the previous row, down 1, which is increasing. Oh, okay, hold on, but if the previous row, okay, so if previous row plus 1 so if the previous row plus 1 causes it to go greater than size less than 1, right? If you try to increase here and you go out of bounds, you have to set previous row equals to 0 here, else previous row just remains the same. Else okay, so if the value that we're trying to place on is already taken like it is in this case for here, well, we're going to take the previous row and column value that we had saved up here, and we're going to increase the row by 1 and leave the column the same. Okay. But if the previous row plus 1 is greater than the size, right, if it goes out of bounds, then we need to wrap this to row 0, right? If that's not the case, then previous row else previous row plus 1, and then we'll set previous row into here. Okay, so then the thing is though, is if the column won't ever overflow in this case. Let's try that. Oh. Ooh. Oh, we're really close. Pause. We're really close here. So the logic is working, right? It's going up, placing. It found that this was already taken, and so it placed the 5 here. 1, 2. And then it's overriding the initial 1. Oh, so then let me go is less than the size. I'm already placing the 1, so let me go 2 to less than or equal to the size. (17, 24, 1, 8, 15, 23, 5, 7, 14, 16, 4, 6, 13, 20, 22, 10, 12, 19, 21, 3, 11, 18, 25. No way, dude! No way! Let's go. No way, we got that. I thought that we weren't going to get that. Let's go. Wow, we got it. We worked through all the logic there. I'm super proud of myself. Wow. I'm super proud that we were able to catch that additional piece of logic there. Nice. Wow, that one was a tough one. And it didn't even really feel that bad. Oh. Let's go. I'm hyped for that one. Let's go. Leave a like in the chat for that one. Let's get some feedback here. Boom. Got the right answer. This is a clean, correct implementation of the Siamese method of magic squares. You didn't luck into this, you earned it by tightening your logic step by step. Oh, let's go. Nice. Oh, that's so cool. I'm so hyped we got that. Okay, so let's walk through that last one. That one was a little bit tricky, in case you weren't with me. Okay, so we print out the prompt. Okay, this is what we're going to do. We have a size variable. We have some logic to make sure the size is within 1 to 99 and is odd. If it's not, we continually reprompt for size. We establish a matrix, which is size by size, a 2D array, and we loop through that array matrix, 2D matrix, and set all the values to 0. Okay? I then establish a row equals to 0 and a column equals to size divided by 2 as my initial row and column starting place. I set matrix row and column equal to 1. I then loop from 2 to size by size, or the size squared, right? Inclusive. To 225 if the example is 5 for the size. So 5 times 5 is 25. So it would go from 2 to 25 inclusive. I then save the previous row and previous column right off the jump before I do any manipulation. I then determine if the increase in row upward, which is in the negative direction. You got to think about it. This going down is going positive for rows, whereas if I were to go row up, that's negative. So I had if row -1 is less than 0, meaning I would go out of bounds, right, into this prompt up here, I need to wrap and set the row equal to size -1, which is 5 minus 1, which is 4, the maximum rows, 0, 1, 2, 3, 4. Else, row can just decrease by 1. Same thing happens for column, but column increases to the right, right? So 0, 1, 2, 3, 4, 5 would be the out of bounds column. So if the column is, I could say greater than or equal to size, but whatever, is greater than size less than 1, right? Meaning the maximum index available for the 5 by 5, which is 0, 1, 2, 3, 4. Then we'll set it to 0, meaning that that column overflowed and now wrapped back to column 0. Else we'll just increase the column. Then what we can say, if now we've determined the next row and column we need to place a value on, the up and to the right, or the wraparounds. We've dealt with that logic. So now what we need to do is determine if that row and column we're about to place on is a 0 that was previously filled in by default, right? Because it can only be 1 through n by n squared for the values. So what we say is if that is 0, then we have to do a similar kind of logic checking because as kind of the row for the column, actually that we did above here, right? Stay with me because in the case where the position is taken, like in this where the 5, we want to place the 6 where the 1 is, but the 1 is taking that spot. So we have to place the 6 right below the current value, which is why we saved previous, right? Previous row and previous column right here. Oh, you got an ad? Rip. Sorry, dude. Twitch be like that. I've been streaming all year on Twitch and I think I've made a total of like $1. So honestly, I think I'm going to turn off those ads. Right? And so what happened is, okay, so we know that that spot's taken, right? The 1 is in that spot where we need to place the 6. So let's go ahead and evaluate if that 6 is, we need to evaluate if that placement of the 6 is going to overflow, right? What if we were right here on this 18? We tried to place where the 19 is, theoretically, and that's taken. Well, we need to place the 19 here. Uh-oh, that's not, they can't do that, so the 19 has to go right there in that theoretical case. So what we had to do is if that previous row plus 1, right, if that previous row plus 1, right, in this case, if the 5 plus 1, right, for this row, just happens to be incrementing by the same digit plus 1. So that's not the math we're doing here. We're doing row 1 plus 1 to row 2, right, because this is row 0. If that value overflows out of the matrix, then we need to wrap. Well, in this case, it doesn't, so we can place. And then we set the previous row equal to row and the previous column equal to the column in that case, or always, right? For wherever we set the value and move forward. Else, we can just place the value by default with no other logic checking, right? We can actually, for just the default case of up and to the right, right? We can place the 8 here because there's nothing there before, and yada yada yada. And this is what we get here. This is the answer. We were able to get this with like pretty much. We got a little tripped up on our logic here. We needed it, but it was just we had the inverse, but that was it. I think we do 5. Boom. All right. All right, you guys. Sweet. I'm super stoked with that. That is super awesome. I'm actually really happy we were able to work through this problem. I might go ahead and chop up the stream and re-upload these couple of problems as some like cool, like just like C practice problems like to the channel as like some just me solving the problems like whatever. These were a lot of fun to do these 3 problems, and they really gave us some good practice through using all of the things we've done so far, declaring variables, importing stuff, the H files, creating matrices, whether single or multidimensional, using print statements, formatting print statements, using scanf, using getchar functions, using loops, using if-else logic. These past like 3 problems have really tied together everything thus far, which has been really nice. And we were really successful tonight. So super, super glad that we were able to work through that. And we finished chapter 8. So let's go ahead and sign off to chapter 8. And chapter 9, functions, is coming next. Functions in C. Should be pretty fun to get into. So make sure you guys be here tomorrow for the read along in functions in C. We'll probably do about an hour to an hour and a half of reading and note taking, and then come back the next day and finish up the chapter. Yeah, because I get kind of tired after reading for a while. But things at my work have been ramping up, so sorry I was a little late today. I've been starting up one of my projects again. I build large chemical solutions, upwards of 1,500 liters, that are pretty like advanced immunoassay chemical solutions of like biological human serum bases. Uh, and so I've been having to do a lot of data analysis and interpretation at work over the past couple of days, getting ready to do a matrix. And I've been using my actual software I wrote for my work, which has been really nice to actually implement the matrix automatically. So I've been having to actually interpret by far the most data I've ever had to interpret. And thankfully, I built this tool, proprietary tool for my company to use, and it's been really really helpful for like identifying what I'm short on and where I'm gonna need to increase my volumes for certain constituents and stuff to actually hit my ranges within the blend. So super super cool that that tool is actually working out really nicely. But I appreciate you guys being here and hanging out with me. Make sure you subscribe and follow along if you are enjoying the C programming we've been doing here. I'm actually really, really enjoying C. I find it to be really fun to write. I can't wait to learn even more about it. It's a relatively simple language, as they say, and we've been learning it for like 2 months here, it seems like, or a month and a half. Um, More than that, I think we started this in November, but just slow grinding through it, really trying to this book is just really thorough. Like I'm sure the KNRC or whatever kind of gives you the basic fundamentals and kind of a list of functions and maybe some basic things. This is really telling you everything that everything does. So, anywho, I appreciate you guys being here and hanging out with me. We're almost to 4,400 subscribers, if you can believe that. So make sure you guys subscribe if you're enjoying the stream. Thanks so much for being here. Howling Fan Tods. What's up going on? I heard you kind of got your thing working. Yeah, we finished up today. Great minds think alike. I had one comment on the line. I had to do this case here for 38 to handle the overflow for placing below you. But is there a better way to do it? I mean, I could have just said um, greater than or equal to sys size, but or I could set it to +1 no matter what. Maybe
You're not that guy, pal.
that's probably
Trust me.
better. Maybe
You're
if you
not that
set
guy.
PR plus
Yeah,
equals
you?
1,
Absolutely.
right? And then you say if PR is greater than that, then set it to here. Else you can just actually do nothing. That'll remove that else statement completely, which is actually kind of nice to kind of refactor this up. Um, yeah, we can increase just the previous row by 1, do the evaluation on previous row, set it to 0 if it comes true, else just keep it and then move forward. You might clean that one up a little bit. Oh. We're grasping, we're nitpicking here. Yeah, sweet. All right. Appreciate you guys being here and hanging out. You guys have a great day. let me know if you guys want me to do something else or what you guys want to see on the stream. Really, if you guys have any feedback or like anything you guys recommend me to learn or try to take a shot at or whatnot, if you want to chat, join the Discord. Link down below. Shout out to everybody that's been Discording me. Sorry, I have a lot of people that have been wanting to like link up, like do like one-on-one like calls and stuff. I really want to like be more like social and personable like with you guys, but honestly, like I just don't have a ton of time, and the time that I don't stream, I really try to just enjoy it to myself because it's so limited. Because I go to work, I wake up at 7, I get to work, I leave at 8, I get to work at 9, I work from 9 to 5, get home at around 6, 6:30 maybe, take the dog out, get some food, get on at 7. And then I'm streaming, and then I'm off. So anytime that I'm not, streaming, it's either at work or that little couple hours from like 9 o'clock, 9:30 to like 11 is like all I got. So usually like I just go silent and I don't do anything. I just like sit on the couch and we'll just scroll or edit maybe a video if I'm thinking about it, but because it's like the last only time I have to really just chill. Um, weren't you working while you drive to work? You aren't working? Yeah, I was taking sometimes I take the public transport, the train, and I'll kind of read or maybe do some editing or it's just not too long of a, like it's only like 20 minutes, so it's just too, when you go by train, um, it's not, so it's just like too short of a trip to really get into a flow, like with coding, so it's kind of like a little bit, just a little bit too short to kind of get into a flow. Like if it was like 30 to 40 minutes, it might be better, but it's only about 20, so it kind of, by the time you get your laptop out and get going, it's kind of time to put it away again. All right, you guys. Thank you guys so much for being here. I know I keep saying that, but let's go ahead and push this up. We finished chapter 8 today. I'm super proud. Git add, git commit, finish chapter 8. What? Finished chapter 8. Why is it doing this? Why is it doing that? Come on, autofill, sign in, GitHub. Hmm. The heck? What? Oh. Durr. Gotta push, dude. Come on. Why is it? Oh, it goes by. Oh, interesting. Oh, that's how it does it. It does it by. Oh, GitHub orders by first character and then by second character. So does it go by multi? Oh, interesting. It's like by bit, like what, like by place. Hmm. We have alphanumerical ordering of the files. Okay, I think we're good. Cool. All right, you guys, it's live on GitHub, so if you guys want to take a peek at my answers for Chapter 8, feel free. Thank you guys so much for being here. See you guys tomorrow.